Bearings. A bearing is a direction measured from north in a clockwise direction and is given only by an angle. Bearings must always be written using 3 digits. For angles less than 100 degrees, we place a 0 or zeros in front of the number so as to ensure there are 3 digits. For example, north is on a bearing of 000 degree, or northeast is on a bearing of 45 degrees. There are 2 ways to express a navigational heading or a bearing. Number 1. When a single angle is given, it is understood that the bearing is measured in a clockwise direction from due north. The bearing from A to C is 30 degrees. The direction is due north, and we have 30 degrees up to line AC, and that's the bearing. Number 2. The other system starts with a north or south line and uses an acute angle to show direction. Acute angle is from 0 up to or less than 90 degrees. And the bearing from A to C is south 52 degrees east, or 52 degrees east of south. So south, and the direction is east. So south 52 degrees to east, and this is the line AC. Next, we have the bearing of a line. L is the acute angle formed by the north-south line and the line L. The notation used to designate the bearing of a line begins with N for north or S for south, followed by the number of degrees in the angle, and ends with E for east or W for west. So here's the example. So we have the bearing of B from A, which is north 40 degrees east. North going to east direction, and we have 40 degrees. So the line AB is north 40 degrees east, and this is the angle or the bearing. And another example, we have the bearing of B from A, which is north 65 degrees west. So we have the north-south direction and north 65 degrees and going to west direction. So north 65 degrees and the line AB, and this is the bearing. Another example, we have the north-south direction and the bearing of B from A is south 70 degrees east. South and going to east direction, which is 70 degrees, and this is the line AB. And last, the bearing of B from A, which is south 20 degrees west. So south 20 degrees and west, and this is the line AB. Example, give a diagram that represents each bearing. Number 1, bearing of 32 degrees. Number 2, bearing of 304 degrees. Number 3, north of 42 degrees east. Number 4, south of 31 degrees east. And number 5, north of 52 degrees west. And we have the north, south, east, west direction. So number 1, bearing of 32 degrees and using the north-south direction. So the bearing is 32 degrees, always start from the north and clockwise direction. So north, clockwise direction, and the line at this point, and the north 32 degrees clockwise direction, and this is 32 degrees. So north 32 degrees, which is the bearing. And in terms of the north-south direction, north going to east direction. So north 32 degrees east. So the direction is north 32 degrees east, which is also the bearing of 32 degrees. Number 2, of 304 degrees using the north-south direction. 304 degrees, so start always from the north direction and clockwise direction. 90, 180, 270, which means we have the second quadrant. So this is from the clockwise direction up to this point, and we have the line, and this is the angle, which is 304 degrees. And to find the north-south direction, we base on the angle theta, and this is the angle. So the angle theta is equal to, we have one revolution, that's 360 degrees, and less 304 degrees. 360 degrees less 304 degrees, and theta is equals to, so 360 minus 304, and that's 56 degrees. Direction north going to west direction. So north, angle theta, west, and this is north, 56 degrees west, and this is the direction for the bearing of 304 degrees. Number 3, we have the north 42 degrees east, and for the north-south direction, north 42 degrees east, so north going to east direction. So we have north, the line at this point, north 42 degrees, this is the angle, and east, so north 42 degrees east. And in terms of the bearing, so theta is equal to 42 degrees, which start from the north direction and clockwise direction. So therefore, the bearing of 042 degrees, which is the same as north 42 degrees east. Number 4, we have south 31 degrees east, and the north-south direction, so south going to east, and we have 31 degrees, so south, and the line, and the angle is 31 degrees. So this is 31 degrees, which is south, 31 degrees east. And for the bearing, angle theta, which is from north clockwise direction, and this is the angle theta. From north to south, that's 180 degrees, which means 180 degrees less the angle, which is 31 degrees. So 31 degrees, and theta is equal to 180 minus 31, and it is equal to 149 degrees, which means the bearing of 149 degrees, which is the same as south 31 degrees east. And number 5, that's north 52 degrees west, north 52 degrees west, and the given north 52 degrees, so north to west, north west, and this is the line, and north 52 degrees, and this is 52 degrees. And to find the bearing, we should start from north and clockwise direction up to the line. So this is the angle theta up to this angle, and this is theta. So theta is equal to, this is based on the second quadrant, so north 90, 90, 90 to 70, and 360 degrees less 52 degrees. 360 less 52 degrees, and the value is 308 degrees. And the bearing of 308 degrees, which is the same as north 52 degrees west. So these are the solution on how to make a diagram based on the given bearing and the direction. Example for word problem. A boat travels on a course of bearing north 52 degrees 40 minutes east for a distance of 238 miles. How many miles north and how many miles east have the boat traveled? And we have the north-south direction. So north, south, east, and west. So the bearing is 52 degrees 40 minutes east. So north, east. And the distance is 238 miles. So point. And we have the angle 52 degrees from north up to east. And this is 52 degrees 40 minutes east. And the distance is 238 miles. So this is 238 miles. And we will find the distance from north direction and east direction. And designate this as x value and this is y value. So this is the distance from the east direction, that's x, and this is y for north direction. So we have the angle 52 degrees and 40 minutes, and this is the opposite side, and y, which is this is y, and this is the adjacent, and the length or the distance, this is hypotenuse. We will convert the angle 52 degrees and 40 minutes to angle. So 52 degrees and 40 minutes and equate that to, first we will have the conversion. 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So convert 40 minutes to degree by 52 degrees plus 40 minutes and convert that to degree, which means 1 degree is equal to 60 minutes and cancel out degree. And the value of 52 degrees, 40 over 60 is 0.667. So 667 and degree. So we have now the angle in terms of degree. And using SOHCAHTOA, we will find the value x and value y. So first, let's find the value of x for the east direction using sine or so. So sine theta is equal to opposite over hypotenuse. And the angle sine of 52.667 degree is equal to, the opposite side is x distance, while the hypotenuse, that's 238 miles. 238 and cross multiply, x is equal to 238 miles and sine of 52.667 degrees. Using your calculator, we can find the value of x, which is equal to 189 miles. And this is due east direction. Next, we will find the value for y or the north direction. And using, we have adjacent and the hypotenuse, which means we can use the cosine or ka. So cosine theta is equal to adjacent all over hypotenuse. So cosine of 52.667 degree is equal to the adjacent, which is y, all over the hypotenuse, or 238 miles. And cross multiply, we can find y, 238 miles times cosine of 52.667 degrees. And using your calculator, we can find the value of y, which is 144 miles. And this is due north. So now we have the distance along east direction, that's 189 miles, and for the north direction, that's 144 miles. And these are the solution. Example: a helicopter is hovering over the desert when it develops mechanical problems and is forced to land. After landing, the pilot radios his position to a pair of radar stations located 25 miles apart along a straight road running north and south. The bearing of the helicopter from one station is north 13 degrees east, and from the other it is south 90 degrees east. After doing a few trigonometric calculations, one of the stations instructs the pilot to walk due west for 3.5 miles to reach the road. Is this information correct? So we will prove that the pilot walk is 3.5 miles. Solution. So here's the diagram. We have the helicopter and landed at point C, and we have the two radar station located at 25 miles north 13 degrees east direction, which is at point A. So this is north, and east, so north 13 degrees east, and that's point A. And another radar station, that's point B, and the direction is south 90 degrees east, and this is south and 90 degrees east. And the distance from point A up to point B is 25 miles. And from point C, where the pilot will walk up to the road, that's 3.5 miles, which we need to prove that the distance is 3.5 miles from point C, which the helicopter landed, and up to the road that is perpendicular to line AB. Triangle AFC and triangle BFC. First, let's have the triangle AFC. Triangle AFC, and the angle is 13 degrees. We have Y, and the distance A to F is X, which means from B to F is 25 minus X. And using the SOHCAHTOA, we have the trigonometric function that's tangent. So Y and X, opposite, adjacent, and the angle. So using tangent, so tangent of 13 degrees is equal to the opposite, which is Y, all over X, which is the adjacent. And Y is equal to cross multiply, so X tangent of 13 degrees. And this is equation 1 based on the triangle AFC. Another triangle, BFC. Triangle BFC. So we have the angle theta, that's 90 degrees, and the opposite side is Y, and the adjacent side is 25 minus X, which is using tangent theta or TOA. So tangent of the angle is 19 degrees, and it is equal to Y, the opposite side, all over the adjacent 25 minus X. So 25 minus X, and cross multiply to find the value for Y. Y is 25 minus X times tangent 19 degrees, and this is equation 2. We will substitute or equate equation 1 and equation 2. Equate equation 1 to 2. So equation 1, in terms of Y, X tangent of 13 degrees, and it is equal to 25 minus X tangent of 19 degrees. And simplify. X tangent of 13 degrees is equal to 25 tangent 19 degrees negative X times tangent 90 degrees. So X tangent 19 degrees. And transpose negative X tangent 19 degrees to the left side. So X tangent of 13 degrees from negative, that's positive, X tangent of 19 degrees, and it is equal to 25 tangent of 19 degrees. Factor out x. X, tangent of 13 degrees plus tangent of 19 degrees. And it is equal to 25 tangent of 19 degrees. Then divide everything by tangent 13 degrees plus tangent of 90 degrees to find the value for x. X is equal to 25 tangent of 19 degrees and divide everything by tangent of 13 degrees plus tangent of 19 degrees. Using your calculator, you can find the value for x. So 25 times tangent of 19 degrees and divide tangent of 13 degrees plus tangent of 19 degrees. And the value for x, 14.966, and the unit is in miles. So we have now the value for x. Then substitute the value x to equation 1 to find y. The value should be 3.5 miles. So let's check. At 1, y is equals to x, which is 14.966, and multiplied by tangent of 13 degrees. So y is equal to 3.5 miles, which is, the information is correct. So this is the solution.